Well, hopefully you've all finished your exit ticket from the lab that we did on Monday, all about the properties of light. Now we're going to go ahead and move on, and we're going to talk about light microscopy. We talked about the electromagnetic spectrum. Now we're going to talk specifically about visible light in the microscopes that we use to help make things viewable. The compound microscope has more than one lens. That's what makes it compound. There are two pieces. The objective lens, which are the nose pieces, those are the ones we looked at in class on Monday. The microscopes that we're going to use in our class will have four. It'll have a magnification of 4, 10, 40, and 100. The eyepiece is also called the ocular. Again, ours are 10x. Different microscopes, some might have 15, but that's the magnification. Now, our microscopes are binocular, meaning that we have two ocular lenses. There are some monocular that have a single ocular lens. This is the cutaway of the lens that we looked at on Monday, and just showing you all the lenses that are in there and how it concentrates the light. The compound light microscope, the light comes from the base up through the stage. Now, we don't have any special condenser, but we're going to talk about those because that was what makes microscopes different. The light will come through our stage into the objective lens and then into the ocular so that we can see it. This is the basic cutout with our light piece. Again, we have the 4 lenses like this. This is our fine adjustment, which is a separate knob. Our coarse adjustment is the large one. We only use the coarse adjustment on low power. We use the fine adjustment to find the specimen in better detail. Our stage, we have a mechanical stage, so we put our slide here, and then that allows us to move it more easily. And again, this is the condenser, or our light. This is a diaphragm. We don't have a condenser on ours. To calculate total magnification, it's the eyepiece times the objective. And we worked on that when we did our Understanding Magnification lab. Our microscopes are parfocal, which basically means it's going to stay pretty much in focus as we go from low to medium to high power. The main thing we'll want to do is make sure that in our field of view, when we have our arrow pointing to the specimen, we kind of keep that in the center. And again, we can use an ocular micrometer for measuring, but we already kind of know what our field of view would be and how we can calculate it. Now, there are different types of microscopy. You had an ed puzzle on the types of microscopy, but we'll talk about them. The most common is bright field, which is what our microscopes are. And what that is we have a bright background based on the light rays coming up through the specimen, and it's a transmission, so the light will go through it. With dark field, there is a lens, and it will cause the light to bend, and it goes around it so that you have a dark background. Here is bright field magnification. You see the light background. Okay. Dark field, you have the special condenser, and it causes the light to reflect. And this is it. It's on the dark background then. Okay. Same image, two different microscopy techniques. This is dark field. Phase contrast, you will use live organisms. Special condenser, again, accentuates small differences in the refractive index. Remember, refractive index is what happens to light as it bends, as it passes through different mediums. Here is an amoeba under phase contrast. You can get a little better feel for the texture or the depth. Micrscopy is a type of microscopy that makes use of differences in refractive indexes to visualize structures. You get a much better resolution with Micrscopy, but you have a very short depth of field. But you do get nearly a 3D image, as you can see here with the Micrscopy image. Fluorescence microscopy, we talked about this property of light. This is when UV light is used to excite molecules to release light of a different wavelength, which is what we did with the stars Monday. With this, you can use dyes. Specifically, fluorochrome is used so that a specimen will stand out sharply against a very dark background. And you can use this for antibody staining, and it's used to determine whether an antigen, the foreign material, is present. And we can get the results in minutes. Here is what fluorescent antibody staining might look like. Again, a special condenser. Now, these are the same object to paramecium with the 4 different techniques: bright field, dark field, differential, and no Micrscopy. Confocal is when you use UV laser light to excite the dye molecules. Light beam is focused onto the specimen either through a thin optical fiber. A computer will then reconstruct the image, and again, you get great resolution, up to 40% better than with other types of light microscopy. This is the confocal microscope system. Here is the under standard fluorescent microscopy. Here it is under confocal. I would think you can see the difference between the two images. That is your confocal. A digital is an autofocus. To be honest, this is probably the kind of microscope in most commercial labs. Auto aperture, auto light, motorized stage, and magnification changers, all under the control of some type of software. And you have a built-in camera and digital software. Basically, you load the slide here, and you get the image here. With this, you can do the measurement. I talked about that on Monday. You click and say, okay, how big is this? You can do magnification. You can rotate it. You can do all kinds of cool stuff. Here is a bacterium using digital microscopy. Okay. Now, we will get into making plates and learning all about the equipment on Friday. So today, just finish the focus, do the focus questions over microscopy, do the exit ticket, and you have an ed puzzle on electron microscopes.